what the? Whoa! Oh no!
You saw nothing.
You saw nothing. How you doing, my friend?
I'm doing good. How are you? How
was your morning?
We did tennis, which was really fun.
Yeah, tennis.
Tennis classes. Which was really fun. We did that in not sure.
You did that in what?
I'm not sure where we did it. I'm forgetting right now, but we did do tennis classes, which was really fun.
Okay. All right. Cool. So I had some fun playing tennis, and back in time to write some code.
Yes.
All right. Today we're going to continue on our vector visualization project. We started this, I want to say, a couple weeks ago.
I think so too.
And we took a break to learn regular expressions. Then we built a code generator to turn our regular expressions into code.
Yes.
And we just had time to insert it about a week ago when we last did the show.
Yeah.
On Saturday.
There is a bug in our code. That is,
we think there might be a bug.
we think, right?
You were just
So
saying
if we do negative 4 space -6 space 2, it will create, here we can see a vector.
It's down there.
Yeah, wait, I'm
Pointing away. The one here is from the old code. We're just putting in one that comes out at, I think,
1, 2,
2,
3.
6, 4, or something like that. Yeah, 1, 2, 3, something like that.
So we can see this vector. Oops, wait.
Yeah, that's the one that's pointing down is the one we just created.
And then our syntax should allow us to do this, and then have 3, 4, 7, and then it will create a vector. Oops, wait.
It's slightly blocking. You might have to.
It has a vector that is should go from -4 to -4, -6, 2, and then it should end up in 3, 4, 7. But instead, it's just creating a vector with both of those coordinates.
Whoa,
Two vectors.
Actually, hold on. That's not quite what I'm recalling. I'm recalling that based on a discussion we had with Pudding, that he suggested the syntax be the last 3 I thought were delta x, delta y, delta z.
Yeah, that's what I'm saying.
Okay,
that's
so
the endpoint, correct?
No, not the endpoint. It's the delta added to the beginning point, I think.
Yes, and it's not really doing that, as we can see.
I think.
If we unmax,
we need to figure out what our syntax is, actually, now that I think about it. I know that that's we've got our parsers parsing it that way, as I recall. Do you remember in our parser, our last 3 parameters were delta x, delta y, delta z?
Oops.
Pretty sure that's the case. Let's look at what's going on here. Here's our create vector called the hard-coded one. We could probably comment that out. We don't need to do that one anymore. Here, we're using delta x, delta y, and delta z. But that, and then, oh, look at this. Create vectors suggesting it's end x, end y, and end z. And start x, start y, and start z. So what did we do here? Did we write, so we had a discussion, and then we changed it up a little bit.
Oh, no, look, here.
Yeah.
Yes.
Okay, so I think the way you were describing it is the way we wrote the code, but the way I was describing it was the discussion that we had with Pudding.
Yes, I think so.
And so I'm kind of thinking, since the code is already calculating, it's looking for end and start points. I think what we want to do...
Wait, I think we should keep it like that because...
Keep it like this?
Yes.
I agree. Let's go change the names of these right here in SuperVector, right? In SuperVector, we have 3 points that are created for us here. I'm hitting F12 to drill in. Do my function locked here? It might be function locked. I hit F11 by mistake.
Oops.
It's not too bad in here. Hold on a second. F12. There's what the key I wanted to hit. Okay, so X, Y, and Z, these are the endpoints right here. I kind of want to rename these. And so this is going to be end X.
And Y and end Z?
Yeah.
Okay.
And Y. Let me rename this again.
Because they're public.
Yeah. And let's make this end Z. And this one is going to be renamed to start X. And this one's going to be renamed to start Y. And that one's going to be renamed to start Z. Now, we might want to also come in here and rename our X to start X. Wait, hold on. These are the ones, deltas are the ones that get renamed to start.
Wait.
Which means I've got to go find deltas in here and rename them to start. There look like there are 3 of them. I wouldn't have to do this. I heard you say wait, but I kind of want to make this code kind of sync up. If we're going to change the meaning of the pieces, when we're working on our regular expression, that's what we have. And then also similarly for X, Y, and Z, this is now end X.
And Y and end Z.
That's named end Y, and that is named end Z. And now we should be able to come in here and change these. We still have vector name in there the same. Okay, so we're going to change our syntax back to the way we were thinking of it originally because of the method here is already taking those pieces in. Is that
Yeah.
too loud for you, buddy?
No.
Okay. Now, then, when we call create vector, we want to pass in all the parameters to it. So we want to start with the end X, Y, and Z.
Wait.
I'll duplicate that, turn it into a Y. Duplicate that and turn it into a Z. Now I think it'll work. Okay? So we're gonna pass in all the parameters that we're grabbing. All the parameters we're getting from what you type in. You want to try that? Also, do you want to move the text so we can see it? It's right at the bottom behind us when we run it. Should we move it in Unity?
Wait, what do you mean when we run it? When we're not maximized?
Yeah, when we're maximized, it's right behind your head, and so people can't see
It is?
what you're entering. I'm wondering if it makes sense.
I think it does. Oh, wait.
Move it.
Oops. That's not what I wanted to do.
Use some canvas. And I think, I don't remember how we changed this, Campbell. We have to change the placeholder, move it.
I think we have to change both. Maybe
What
not.
about the input field, the parenting input field?
Oops.
I'm wondering if that changed. Undo what you just did. Try the parenting input field.
Oh, maybe.
That's the height of it. I want to
Oops.
change its Y, not its
Yeah,
height.
that's not what I meant to do.
See if you can move that Y so we see it. Now run it. Just try there running it. It might be too obnoxious, but we should probably put it all the way to the top. Now let's go and put it all the way to the top. We can anchor it too, it looks like. By hitting the anchor button, anchor in the upper top center. Before you change the Y. Yeah, there. Now change the Y to 0. Or something like that. There you go. See what's happening?
I think that's the right place.
The
Because when
position
we
Y
play...
is based on the anchor. I think you got it off screen a little bit. Make it like 0. Just type in 0. Click the field and type in 0.
No, because that will make it higher.
It'll make you drop down, okay?
No. Because it's negative right now.
It's positive before, as I recall. Oh, you're right. It does go higher. All right, so we got to get it way down. All right. Hey, it's Campbell Codes in the house. That's got an amazing drone show that he's been producing.
Oh.
Yeah. What are we doing? How are you doing on that?
I'm just getting it.
All right.
Close.
Cool. All right, so let's type in something that starts at 222. Now we just do 222. Okay, it gives me a vector going from 222 back to 0. It's kind of pointing the wrong way. Do a comma and say 555. I mean, not a comma. Do a, yeah. Goes out to 555 and see what's going on. 555.
Oh.
So it's reversed.
Not what we wanted.
Right? Don't we want the start?
Wait a minute. It's starting at 225 or ending at 225.
Oh, yeah. You know what? We set it up so that our start was the first parameter we ended. The point we wanted to point to is the first one, which, okay, now I'm like, so this it won't be here long. Mark, apologies in advance for distracting Campbell with my drone formations. No worries. Although buffering has already started, so I think I might have issues. Okay, well, that's not good. Your buffering is, I think, on your end, because it looks like over here we've got 4,000 kbs going up. Okay, so the other thing we have that's going on here is every time we make a change to this, it creates a new vector. It doesn't, you know, kind of replace the existing vector. Yeah, you know what I want to do? Oh, man, I don't think you're gonna like what I want to do. I want to go back and undo what the changes we did in SuperVector, and I want to go back and change our code instead. That's what I want to do. Where's my SuperVector?
It's right there.
Oh, there it is, right there. Oh, it's all new. Shoot, we didn't commit it because we pasted it in last time. So I can't undo easily there. I'm just going to have to undo it one at a time over here. So let me just do that. Let's see, how many did we do? Let's keep doing a lot of them. All right, so now we've undone all of these changes here. And that should also impact changes over in this space as well. So now we've got delta x, delta y, and delta z that are going into create vector. And vector is taking this weird end x, y, and stuff like that. We're only calling it from this one place now. So what I want to do instead is I want to have delta x, y, and z as my options. And I also want to be able to pass in the other components of it, x, y, and z. And the last one is z. So then we're going to bring those in. So we're going to say x, y, and z are going to be my parameters. The length, so here's the question. I guess this is the question. I think this is the question. This is what it points to. So when we type in, the first thing we type in will be what it points to. If we don't specify the next set, it will, well, it's probably going to assume delta x, y, and z are all 0. We should probably set them all to 1, is what I'm thinking. Would you agree with that? Because if they're all 0, we won't see anything.
That's true.
Which are doing the lower resolutions that I can usually watch on. Oh no, that's not good. Here come the drones, Campbell. Check out the formations. I love how you're trying to look at where the drones are in real life here. Let's do this, actually. Let's actually pass it in the starts as well. But we'll calculate the start from here. Oops, that's not what I wanted to do. So what I'm thinking is this, Campbell. We say, hey, look, we're going to say, are these doubles going in? I think they are, right? So we're going to create a new variable type double. And this is going to be our x length. I guess I just call this delta x. No, x. No, I've already got it there. It's x start. Like that.
Wait a minute. Aren't the delta y, delta z, and aren't they just? Oh no, they're not the length, are they?
That's what we decided to make them, right? But we called them delta z before, and it was kind of it was based on an idea that if we're going to have to type these in, the most important thing to type in is not where it starts, but what it points to.
Ah. Okay.
Oh, but then the length is, you're right, the length is wrong on this, isn't it? The length is wrong. No, hold on. But we wanted to add them. We wanted to be able to add the vectors here. So hold on, let's go over to let's start up and let's talk about this in PowerPoint for a second. Talk about what this looks like. Switch over here to my machine on this. And so if I have a vector like this, there are a couple ways to define it. One of the ways I can define it is by saying what my endpoint is, or my tail point might be equal to 0, 0, 0, like that. And I might have another piece up here called my the arrow point, and that might be 1, 2, 3, whatever that is. So that's one way to define and create a vector in three-dimensional space. Is basically give it 2 points. Okay? Got that or no?
Yeah, wait. Yes, I think so.
So just 2 different points, right?
Uh-huh.
It's the same if we're just talking about like in one dimension it'd be a number line, so we'd still give it 2 points, right? We give it some sort of start, like maybe 5, and some sort of end, like maybe 10. Okay? Like that. That's one way, right? This is 2-dimensional space, and over here is, down below is representing kind of 3-dimensional space. Okay? That's one way to do it. Another way to do it is to sit.
That's more one-dimensional. What you're...
This one is one-dimensional.
Yes.
That's one-dimensional right there. This one is 3-dimensional because I got 3 coordinates.
Yes, so there's not really a 2-dimensional on the screen now.
That's correct. I don't have a 2-dimensional on the screen. Okay? So I'm just kind of showing you across dimensions what's going on. Now, if another way to do it is to say, well, this is really just +5. And now I don't know where it is in space anymore. It's just a +5 vector.
Oh, okay.
Okay? But we know its direction and we know its magnitude, which is what you need for a vector. And what that also means is here is that this vector now becomes just 1, 2, 3. If I can just type in there 1, 2, 3. Yeah, there we go. 1, 2, 3. Because it doesn't have an endpoint anymore. And I just subtracted the start, the end. I took this minus that. And since that was all 0, no big deal.
Oh!
Right? So that's another way to do this, but now we don't know where it is in space. This is perfect for adding. If I want to add things together, I can add them like this, and this is perfect for adding too, right? I can add them like this. Does that make sense?
Yeah.
So for adding purposes, that's super cool, right? That's the kind of thing that we're looking for there. We could do this. We could assume that every vector I'm starting to think that a vector is just going to look a lot like this, Campbell. That we're just going to say the vector is equal to 1, 2, 3. Later, when we say it's going to be added to something, right, then we're going to have to decide what its offset is. And if we're going to hold it here, just like if we're going to hold it here, we would need another variable to store the start. We need a variable to store the start, where that is, to be able to position this in the right spot. Do you see that with the 5, the plus 5? If we wanted to draw this on the number line, we would need to know where to start to draw it, right? If we wanted to add it, we'd need to know the start position. Okay? Similarly, even though we know the size of this, we need to also know the start of it. This is kind of what Pudding was getting at. Pudding was saying that if we define our vector, we want to always have the delta x, y, and z, right? The start is the optional piece. So when you create a new vector, when we create a new vector over on your machine, let's go switch to your machine and look at this code here and see if we can correlate with what we just connect it with what we just wrote down here. So the super vector gives us right now two parts of it. It gives us an x, y, and z, and I forget which is which when we just type in 3. I think what I want to do is I want to set a breakpoint here and just type in 3 values, and let's see if we make that work. Let's click on Attach to Unity, and I want you to type in three pieces. You're going to hit that vector every time we change the text. Oh wait. Hold on a second. Let's stop. We haven't run yet. Are we running yet? We're not running yet. Okay. Hold on. Stop debugging a second. I want the breakpoint here. If you're confused, I'm trying to answer a question that I'm confused about right now. And once I get the answer to that question, I'll be able to continue with explanation. Okay? So we've got a breakpoint. We've attached to Unity. Start up the game and enter 1, 2, 3. And the question is that going to be a delta, or is that going to be our endpoint? I'm hoping it's our endpoint. That's what I'm hoping it is. And super vector, it's our delta x, y, z. That's our size. And so this x, y, and z is really our start x, start y, and start z. That's what I believe is the case. So the first thing comes in is our deltas. Okay, give me the second component of it. Add the arrow and then do like 4, 4, 4. If you're at a breakpoint, just run it, keep going, add the arrow. 4, 4, 4.
Oh, I had a breakpoint.
Okay, cool. All right, so now SuperVector has got delta x, delta y, and delta z as its size, and x, y, and z now have the values that before were our delta x, delta y, and delta z. So it's kind of, we've got a mistake in the way the regular expression is returning the values to us.
Okay.
That's kind of what I'm thinking. What I feel like we need to do, let's go ahead and run and we'll stop the program. Let's stop it here. Let's go back to our regular expressions tool, which right there, our Reg Explorer. I think that's it. Let's run it and let's take a look at the regular expression. And the problem is here. This is what we want to look at. It's this part over here as we're making changes. I think we got to kind of decide what our syntax is going to be as well when we type this in. And so we kind of started with this, and I think we made a mistake. Let's create a new slide over here. Let's go to my machine. Let's talk about syntax for a second, Camel, and see what makes sense for us to do. Syntax for declaring vectors. We've got a couple options here. We've got easy option number 1. Easy option number 1, it's just A equals 1, 2, 3.
Okay.
And that's all it is. And then from there, we just assume the tail is at 0, 0, 0. Okay, you with me?
Yeah.
Not so easy option, but not too hard. Not too hard option. Number 2, and I think we're close to this actually, is A equals this, or A equals 1, 2, 3 to 4, 5, 6, and now we have tail is now at 1, 2, 3, right at the beginning of it, and point is at 4, 5, 6. So our convention is the last 3 digits are always either here, these 3, or these 3. The last 3 digits are always the point, and the first 3 are the optional tail, if not specified. That, I think, is what we were thinking it was going to do. That's at least what I was thinking it was going to do. And it's not. So I kind of feel like we need to move into this space. So what that means here is we kind of need to play in this space here. We need to say, okay, well, what is this going to be? Somewhere in here, and this is like getting to be a mess to read and parse this thing out.
Wait.
What'd you say?
Are you on my screen right now?
I'm on your screen, yeah. Thanks for switching me back over there. Somewhere in here, like I think it's right about in this space here, is the second part of this. Right there. It's the second part. And what I want to do is make it the first part.
Okay.
So I want to get rid of this. This is, I think, this entire piece right here. Is what I think it is. And then I want to do, or actually it's not. It goes from here to here. And then what I want to do is pop this in. So now my wait. It just occurred to me. We're building this using our code. Did I just close down? It looks like I closed that down. Didn't mean to do that. Let's bring it back up. Let me select as unavailable. Where's the regular for? Oh, right there. Okay. All right. We built this in the code. Vector name, click.
Yeah.
Vector name equals this. This is my assignment. Make a vector. Here's where I'm calling the vector. We're passing it in, and we're passing it in a prefix. All right, here's where we want to change it around a little bit. This is the optional prefix. So this is going to be the start. That's going to be my prefix right there. So this will be start X, Y, and Z. And this is going to be my end, which is also known as like, so maybe some kind of calling this start, maybe call this tail. Tail? Yeah, I think that's going to be good. So we're going to say tail to end, and then we need to look at this is the part that it says is optional from here to here. So that actually is feeling and looking good to me now. Let's try running this a second and see if that's correct. So if we come in and say 1, 2, 3 here, wait, why didn't that have a change? Oh, vector long click, I see. I see, I know what's going on. We have just some default text in the text box when we start, but if we come in and choose vector long, then it'll get it. Okay, there we go. So there's the changes, Campbell. See that right there?
Yeah.
See how it has 1, 2, 3? So that, the tail is there, the end is here. Maybe we should just call it X, Y, and Z up there for the right side of these, 2, 2, 2. So now if I just give it just these, those tails should go to 0. Good. So those good tails went to 0, and now I've got end X, Y, and Z. Okay. So let's go. I'm going to change it just to, I'm going to get rid of it here, so it's just has X, Y, and Z. Oh, look who's here, kids. The Coding Girl is here too. Hello, Billy 3131. What are you guys doing? Sorry, I didn't see you there in the chat room. Yeah, we are working on revising. We're integrating code generation, regular expressions. What'd you say, Campbell?
Did I press that button?
Sorry?
I think I might have.
No, no worries. And we're getting that all working. Are you pushing?
Sorry. Oh my stream.
Are you pushing these buttons, man?
Not on purpose.
Okay. You might want to move the stream deck away from wherever you are. I want to do this, and I want to generate this. I want to try this code. So let's come in here. We're going to say pattern vector long. We're going to do that, and now we're going to get X, Y, and Z with tail X, Y, and Z, which are, so we can say here's from tail to head for the vector declaration like that, or we could just leave out the tail, and it will assume we're starting at the origin like that. So I'm going to do that. I'm going to call this my super vector, like this. I've got generated code down here. I'm going to copy that code. So this is from the show we did last week. Then I'm going to go paste it in to our visualizing vectors piece, which is currently running. Here, we can stop debugging this. Let's go to our super vector and change it. Replace it with this code that we just generated. Looks like match collection needs to use that. All right, cool. All right, and so now we're going to, in the game logic, we're going to create that. Now that we have that, then we're going to come in and call create vector with it. And create vector is going to take the end point, which is just X, Y, and Z, and the optional starts, which are going to be tail X, I think is what it is. What do we call it? Tail X, like that. Tail Y, and tail Z. And those are going to be assumed to be 0. I'm going to rename these. Because we were thinking start, you know. Camel?
Yeah.
Are you with me on this?
Yeah.
Do you want me to make you do more stuff so I can't tell if I'm like losing you or not.
No,
and then and X, Y, and Z, we're just going to make this be X, Y, and Z. That's X, and this one is Y, and this one is Z. So now our convention is a vector has an X, Y, and Z, that's what it's pointing at, and may have an optional tail. And if it doesn't have a tail specified, we'll set it to 0, 0, 0. That makes sense?
Yeah.
Are you with me on that? Okay, so now with that change, let's just run it. Now remember, every time you make a change, it's going to create a brand new vector. So let's just run it, see what happens. Can you run that for me? The first test would be like to type something in that points in some quadrant. Okay.
Yeah.
So there, notice it assumes 0, 0, 0.
Yeah. Okay.
Now type in 1, 2, 3 all the way to 4, 5, 6. And see what it did? It added it to it.
Yeah.
So we can define a vector in two different ways. We can either say it's just a point or it's 2 points. Okay, you with me?
Yeah.
All right. We can also do this. We can say, hey, A is equal
to
that.
Yes. But how does that change it?
Nothing. We're not writing any code yet, but we're
Okay.
going to do that. Because I want to be able to then come down and say, I want to be able to say A. Oh, you know what? We need more space here. Because I just went to the end of the line and hit enter, and we lost the cursor. We need to be able to put more lines here and make the font smaller. Can you do that?
I think so.
Yeah, allow me to have at least 3 lines of code in here, maybe. You have to individually change the font size for both of those. Is that true?
Yeah.
I believe it's true. So the drones look random, but they, well apart from one stubborn little bugger, are all following the same path. Are you seeing it right now? You gotta miss that. Can you try that and run that, see if you got 3 lines when you're ready?
Oh, yeah. I'm not sure how to change the number of lines that can be
I think it's built in. I felt like the reason the caret disappeared is because it went to the next line, but it couldn't be shown because there was no room.
You think?
That's
So if I do 9 and then enter, no, that still doesn't do it?
Still goes away. Okay. Alright, so we'll just have to replace the line. We'll have to work on that a little bit. Okay, so now, I think what I want to do now is I want to have a live vector. It's just one vector that we always have shown. And if whatever you type in, instead of recreating a new one, it'll replace it with what you type in. Let's do that now. When you're ready.
What? I'm trying to get the font right. This is just a test.
Small.
Yes, I'm just testing to see if it works. I don't think it is built in. Yep, we always lose the cursor.
We lose the cursor no matter what. Okay. All right, so let's make it big again because no point in, put it back at what, 40?
55 it was.
Okay. All right. Cool. All right, let's create a live vector. So in order to do this, we need to create a variable of type GameObject.
Okay.
That's going to hold our live vector. You just take that line 9 and duplicate it. And then call it live vector.
Is it going to be public or private?
It can be private. Yeah, I just need something, a variable to hold on to. What the last thing we created is Campbell, and then I want to, get rid of it.
Alt up and down keys aren't working.
That's right. We're putting it at the beginning of the word public and see if that works. If there's any difference. Hit home. Looks like you're hitting control, not alt, but try alt. Okay, interesting. So that's
it's doing the thing that it used to do.
Yeah, that's
it doesn't have the code rush feature in.
Yeah, that's I think you have to get in just a little bit right here. You have to be inside it. If you're here, Visual Studio's line up and line down. If you're here, it changes like this. See what's happening?
No, not at all.
Okay. Look what I'm saying. If you're here at the beginning of the line, Visual Studio's feature executes, which is to move the line up or down. If you move to the right one caret.
Well, then mine wasn't working in all of the other ones.
Why? Because I think we were always out over here. We were inside the text, and CodeRush said, oh, okay, I'll do my feature. So.
No, it wasn't working before when we were inside the text.
Well, I'm not sure. You're asking me to like somehow remember that, and that's way beyond my abilities to do that, so I won't be able to give you an answer on that, I think. All right, so we got live vector copied to the clipboard. Let's move down.
Wait, no, it has to be public, right? If we're going to assign something?
No, I don't want it public. This is going to be private. We're going to use it to track the last vector we created.
Okay.
So scroll down to where we're creating a vector. Right here, this is called a create vector.
Wait,
look at that.
Can I?
See that?
Yeah.
I want that to return, instead of not returning anything, I want that to return a game object. I want it to return the game object that it creates. See, it's returning a void. TGO is the fastest way to get to it. T for type and GO for game object. Okay, and let's make it return it. Figure out how to make it return it. See if you can do that. It's not going to be there. It's not. You're inside a for loop right now.
I am? Oh, I am. Oops.
Try to delete that line and try somewhere else. Fastest way to select the line for deletion is to go hit home, get to the beginning of the line, and then shift down arrow to select the whole line.
Right here-ish.
Yep, somewhere in there. If you just hit R space, CodeRush will, you paste it. Try R space. But without the, the line above you. You don't want the line above you. Remember shift, let me show you the fastest way to select the line to delete it. Home, hit home, hit home, hit home one more time to get to the very beginning of the line. And now shift down. And now you can hit enter or delete, whatever you want. Okay? All right, go back up there, type in R space to get your return. And now we want to return a game object. What game object are we going to return? That's a type. I want an instance. You're returning a class, I want an instance. What's the instance? What instance variable here are we returning? Nope. That's our field variable that we're going to somehow assign later. That's outside of this. Field variable has not been assigned yet. There's something that's been assigned in this method that is a game object. Look for it, and that's what you're returning. Drop a marker here if you need to scroll away from this position so you can come back. Good.
Cone?
Yep. That's what it is.
But that's not... Okay.
It's cone. Tell me what you think about cone. It's not what?
It's not the vector.
Kind of, because the name is wrong, isn't it?
I guess, but it's also...
Remember when we built this, the original code? We were also, look at the commented code. We used to build a cylinder as well. Remember that?
Yeah.
Then you had that brilliant idea last time, which is, wait, you were like, wait, let's put the cylinder inside the cone, right? And I was like, oh, that's brilliant, Campbell, great idea. So that we could then change its anchor position so that we just extend the length and it automatically does, it creates the length of that automatically. Right?
Okay.
So what that left us with was a bunch of commented out code that I just got rid of and a variable that's got the wrong name. So let's rename this. Just call it vector. And look out, Campbell. Someone's right above us.
Uh-oh.
Goal! Code says if you have it turned on, you can cut a line by pressing Control-X with no selection. Yeah, with CodeRush in there, CodeRush has got a feature as well that kind of kicks in. And for that to work, you have to be at the very beginning of the line. And CodeRush will ignore it. In other words, nothing, no carrots on no text at all. Okay, so let's see. Called it vector. Fine. Now, let's go up to the place where we call it and assign it to live vector. Assign the results of this create vector call. So just put the caret on create vector, tab to next reference to go find where it's being called if you want to get there quickly, or scroll up and find it visually.
Couldn't it just tab?
Yep, that's what I just said.
It does
yep, there you go.
Already,
now, assign the results of this to live vector. Do you know what I mean when I say that? What's the change going to be?
I can't have this specific method return something, can I?
This does, we just changed it.
No, but this specific call of the method?
When you change the declaration, it changes all calls.
But can I change the specific, when I call this method this time, can I change what it returns?
Maybe I don't understand the question. This is going to return a game object. The game object will be whatever you type in here, right? Whatever pieces you have here typed in. So the question is, can I change it from here? No. If you want to change what's created, you change the code in here.
However, for that specific call.
Yeah, you could have 1,000 specific calls and the answer would always be the same. You can't change it because this code just is going to execute. Once you get it back, you can do something with it. What I want to do is take the thing that is returned this. I basically want something that looks like A equals that. This is what I want, but I want live vector here. Like that. That's what I meant when I said, can you assign the result of create vector to live vector? That's kind of what we're looking for there. Because now we can hold on to it. And if we're holding on to it, we can say, hey, if live vector is not null, then we can come and say live vector dot, what is it, destroy? No, I think we have a destroy call here, right? Destroy and pass in live vector. That's the change I wanted to make. With this change, Campbell, we will only allow one vector to be available at any time.
Yeah.
Can we test it and see if that works? And if we can only allow one available at a time, that's perfect, because then we won't have a whole bunch up every time we make a change. Now make a change. We still only have one?
Uh-huh.
Okay, cool. Nice. All right?
Yep.
Are you with me? All right, cool. Next, now we're going to do something. We're going to learn about. We're going to do this with lists or dictionaries. We're going to maybe work with lists, I think. I think that's what we're going to do. Let's talk about lists for a second. Because what we want to do, and I'll come over here. Maybe dictionaries, maybe lists. I'm still in my head going back and forth on this. So what we want to do is lists or dictionaries. Both of these are good for holding things. Good for holding on to similarly shaped items. What I mean by similarly shaped items, I'm talking about the same class. Does that make sense?
Yeah.
Not the same instance, but the same class. So in other words, I can create a list of cookies. I'm not holding cookie cutters, I'm holding cookies in my list. I can create a dictionary of cookies. I can create a dictionary of candy, right, from Halloween candy. Watch the movements on the bar right there. CodeShare.io. What are we talking about, Surly Dev? So I can hold on to similarly shaped items. The difference between the two is that a list has the items in an order, essentially, and a dictionary
just has them all with their definition.
It really kind of maps a key to an item, useful for very fast, fast access. Okay, so dictionary may be the way to go if we're worried about fast access, that sort of thing. Talking to pudding, okay. Cool, cool, cool. Oh, all right, Surly is helping Pudding create his own drone fleet so that Pudding can spell out the word pudding with his drones. That's what he's working on. So dictionary maps an item to a key, useful for fast access. I'm just going to kill some of these drones here for a second here. With the dot coming up here. Let's see what's going on. I think we'll use a dictionary, is what I think we'll use. Okay? All right. So dictionary has a key, and it has a whole bunch of similarly shaped items in it. That's what's going on with the dictionary. So I will say this though, the list is easier to use. Easier to use. And so now because this is a Kids Code show, Campbell, I'm thinking we go with easier to use. We're not going to do a dictionary, we'll do a list instead. Okay, are you cool with that?
Okay.
Okay. So switching back.
I don't really know what either is, but.
Well, it's a list. Imagine a bag that holds only cookies. They're only similarly shaped cookies.
Yeah.
That's what the bag does, right? But they're in an order. They're in a sequence. So if I say, you know, you give me all of them, you're going to give them to me in the exact same order every time. That's what a list is. I need a list to hold all the variables you type in. When you type in to the code, back over to my machine here a second here. When you type in A is equal to 1, 2, 3, I need to put that inside a list. That's what I need to do.
Ah.
We need to put this in a list. Why do we need to do that? Well, because later I might say, what's A plus B? Or later I might say A dot set color to red. Well, how do I know what A is? I got to go to my list and find it.
Oh.
Make sense?
Yeah.
Okay. I also believe that what is the thing we're going to put in the list? I think it's a supervector. Okay? Because the supervector's got its own name. The only thing the supervector does not have, oops, switching back over to your code over here. The only thing the supervector does not have is the game object. But it kind of needs the game object, Campbell. And the reason why it needs the game object, here back over to my machine for a second, is because what happens if later I do this? What if I do that later? So I've already said A is one thing, now I've changed it and say A is something different. If we don't have it in a list, we're going to now have two vectors out in space that are both called A. right?
Yeah, because we're deleting them, right?
Right now we're deleting them, but the ones that are named, we're only deleting the live ones, but the ones that we name, assigned to a variable, we'll keep around. And so what happens if I do this? If this happens, I have to delete it. I have to delete the old one. Are you getting this, or do you have questions on it?
But
why would I have to delete the old one?
Well, you would have to delete the old one, or else we would have two vectors.
That's why. And so if we have to delete it, we need to put A in a list. So if I come in and do it, I have to first, the code looks like this. It's going to look like this, Campbell. If I have this combination, right, from here to here, it's kind of like this. It's like, you know, user types this in. Later, user types this. Okay? So here's what happens. After user types this, what do? We're going to create the new what? Are you making noise? Is that you?
Oops, sorry.
Create the new super vector. We're going to draw the vector. We're going to add the game object. Right? And we're going to put that super vector in the list. Okay, you with me on that?
Yeah.
Why do we put it in the list? At the very least because I said it was important, right? Okay, you know that we create the new super vector. We're already doing that. Adding the game object, we're already doing that. You agree with that? Okay, we put the super vector in the list. Later, user types this. What do? Oh no, panic, panic. Well, we're going to go like this. It's going to be very similar. We create the new super vector, add the game object, cool. Put the super vector in the list, sure, fine. But maybe first we're going to say check to see if A is already
set to something
in the list. If it is, delete that game object. See it? That's what we need to do. Uh-oh, delete the game object. We don't have the game object. That means we need to be able to add the game object to Unity and to the super vector. So
right,
here we'll say it's in the super vector. We just put it there. What'd you say?
Access it from the super vector. So
say it one more time.
Because we're trying to access it from the super vector.
Right, exactly. Exactly. We're going to put it in the super vector, which means we need to add a property. We need a field. We need a field or property. Okay? With me on that?
Yeah.
Notice the only difference between these two, if these are the logic, this and this, the only difference, because actually this piece right here is now changed to that piece right there. So the only difference are these two lines here. Let's pop those up here. And now I realize that no matter what, this is my new method. My method is, the first thing I do is check to see if A is already in the list. If it is, delete the game object, create the super vector, add the game object to Unity, put the super vector back in the list, or replace its current position. That's our logic for what we need to do. Once we do that, we're going to be able to say A equals whatever, and draw A out there, and B equals something else, and later come back and change A, and the A vector will change, but the B will stay solid. Okay?
Uh-huh.
Are you with me?
Yes.
One more thing, just one more thing is, what happens, I'm going to do a new slide on this, but what happens when user doesn't specify a vector name or a variable, whatever you want to call it, right? What happens if they don't type in A equals, right? What happens if instead they just say 1, 2, 3, like that?
Then it gets deleted the next time we create a vector.
We're going to use live vector for that. Live vector is going to always be able to handle that space. Okay? We've already got code that does that. We only need to now the only difference is we need to say, okay, we're going to use live vector only. We're going to use live vector only if supervector does not have a name. So we're going to go like this. Create a boolean called unnamed, and that's equal to supervector dot vector name. Actually, there's a call inside of string here. Hold on a second. String dot is null or empty. So if it's null or empty, vector name, then that means unnamed is going to be true.
Ah.
Okay. So then we're going to say, well, if we're unnamed and live vector is not equal to whatever, destroy live vector. And also, before I do this, I want to actually introduce a local for this here. We're going to call this vector game object like this. And then we're going to say, again, at the end, we're going to say, hey, if unnamed, then we're going to assign vector game object to that. If it's not named, okay? Otherwise, now we're going to add an else here, and we're going to add an else down here as well. We've got some stuff to do in here. So if down here, oops, hold on one second. All right, it looks like this. If we're unnamed, then we're going to go in here. We're going to check to see if the live vector is there and destroy it, if it exists. Okay?
Yeah.
I might extract this to its own method and just call it destroy live vector if it exists. That might be easier to read. Okay? So if it's unnamed, we're going to destroy the live vector if it exists. Otherwise, we're going to remove named vector. Whoops. Whoops, 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 whoops. Remove named vector, and we're going to pass in the name supervector dot vector name. From list, remove named vector from list. Maybe we'll say remove named vector like that. And then down here, we're going to say add named vector. This is going to add it to the list. And we're going to pass in the supervector, and we're going to pass in the vector game object, both of those. You kind of need both of those together. Or maybe a better way of doing it actually is this. We're going to say supervector dot game object equals that. Can you do me a favor? Can you declare everything that's undeclared?
Yes, I can.
Looks like pudding is getting ready. Supervectors have tensor product defined. I don't know what tensor is. You gotta make me look up things now. What's tensor? Looking it up. Mark Miller goes from being uninformed to being informed on the word tensor. Tensor is an algebraic effect that describes a multilinear relationship between a set of algebraic objects related to a vector space. Objects that tensors may map between objects that tensors may map between include vectors and scalars and other tensors. Okay, I'm still a little lost on what a tensor is. Okay. You can declare it as property, field, auto-implemented, or field, either one. Does not matter. It's just asking where you want to put it.
Here?
Just hit enter. Yeah, that's fine. There it is. Oh, you call it game object. I thought I called it. Oh yeah, that's fine. That's what I called it. All right. All right, so we got remove named vector, add named vector, and we've got the property that we added. Remember that property so that we can go delete it later. If we're going to remove it, we need to be able to find it. We're going to use lists, and we're going to have a list of super vectors. So here's what I'm going to do. I'm going to copy super vector to the clipboard. Why don't you do this, Campbell? Hit copy right here. I'm going to show you how to create and declare new lists. Go up on line 28 where it's empty, and you want to create a new list. So you're going to type in N for new, L for list, and lists lists work with things of a certain type. And so we're going to do a dot for of. So new list of. And just so you know, if you typed in I for int and hit the space bar, watch what happens. New list, no, new NL.I. It's going to be NL.I.
Oh.
Shift home is faster to get rid of it. Also undo would probably be faster too. NL.I. New list of ints. Wait, that was a space bar? That was weird. NL.I. Interesting. So hit escape. Oh, there we go. That worked. Cool. That's a declaration of a list. And notice what's in the brackets.
Int, yeah.
Int,
but
int,
if we
int.
just did it regularly, it would give us whatever's on the clipboard, right?
Right, exactly. So do NL dot and then the backslash, which is above the enter key.
And this will give us
and then space. That should do it. All right. And so now we're going to call these our known super vectors, or our or super vectors, or something like that. Give it a good name, whatever you want to call it. What I was asking if you know, super vectors have a tensor product defined. No, they don't. I say it's just another word for matrices. Oh, okay. Campbell, do you know what a matrix
No.
is?
I don't think
we've not discussed matrices yet. Since this is private, make it lowercase.
Okay.
Remember, control left and right arrow faster for getting there. So, this way. All right. So now, if we want to add the name vector, we're going to come in here and say supervectors.add and pass in supervector. That's as simple as that it gets to add it to the list. See it?
Yeah. Yes.
That's all I have to do.
Wait.
And notice if I bring up the tooltip by hitting Control-Shift-Space, it knows that supervectors needs to add a supervector. This is what's so cool about these lists. These angle brackets say that this list supervectors only works with supervectors. In other words, if I come in and say, hey, list.add, and I try to add a 4 to it, look what happens.
It says that it's wrong.
Yeah, what if I say, oh, I'll make it a string then instead, like this. And look, it says, no, sorry, it's wrong. But if I were to create a new list of strings, see the syntax up there?
Yeah.
The code syntax for that? And I do this and call it my stir list, or whatever that is. And now come down here, if I try to come down to my supervector, this, and I try to add it with my stir list, it says no. But if I come down here and try to add hello into it, it says yes. See what's going on? Stir list can take a string, the stir list cannot take a supervector. See what's
and if we, wait, before you delete all of it, if we come over here, it says cannot convert from string to supervector.
Right. This is what's so beautiful about generic lists, which is what, and they're called generic because of these angle brackets here. Meaning, I can decide right now when I'm writing the code what I want the list to work with. So it's going to be very, what's called type safe. In other words, it's going to keep you from making mistakes like this, right there. That's what's going to happen. So add name vector is super easy. It's just supervectors.add. That's all we have to do. Remove name vectors a little more. What we need to do is we need to say, we need to first get the vector. I think there's like a find or something like that. Let's do first. Let's grab first because we're expecting first or default. I think I have to, I'm going to just type this in a second and see if I can get system.link in there. Okay, there we go. And then I'm going to look for, and I'll explain the syntax in a second. I want to see if vector name is equal to vector name, like that. And then I'm going to declare a local for this. So what this is going to do, this line of code here, Campbell, we'll call this matching vector.
Wait, we are Wait, are we checking to see if x is equal to x dot vector name?
Right, yeah. I'm going to explain this right here.
Wouldn't we do two equal signs then?
Yeah, here's what's happening. This is shorthand that says, hey, I'm going to deal with I want to ask a question about my vectors. And I'm going to call the variable x. I can call it whatever I want to. I can come in here and rename it. I can just, test or something like that. Okay? And then this means my code is going to follow. So this says, here's the variable name I'm going to work with. And here's the code that follows. And then watch what happens when I do dot here. I've got tail x, tail y, tail z, x, y, and z. And also I've got vector name. These are all properties of supervector. So what's going on here is we're calling a method called first or default, and we're passing it essentially a little mini function here. And this mini function is just going to return true if the vector names are equal to each other. So it's going to use my mini function to find the first one that this returns true on. And if it finds it, it's going to pass it back here, or it'll give me a null. So in a single line of code, I can go out and find all of those things right there. Puddings wants to explain some matrices. You know how when you line up some numbers, it becomes a vector, and each of those numbers defines the magnitude along one of the axes?
Yeah.
A matrix would be the same idea, but aligning a group of vectors. So you'd have 1, 2, 3 at top, 4, 5, 6 below, 7, 8, 9 below that, and it looked like a square. That is exactly right. So if we want to we're just going to jump ahead. This is like about maybe a year ahead in math right here. Switch over to my machine.
Yep.
Matrices, right? And they essentially look something like this. 1, 2, 3. We put a little more space between those, like that. And then 4, 5. Looks like it's got some of my spaces. 6. And I'm not sure what it's doing. It's predicting what I want to do. I'm not sure exactly what it's doing at all. But that might be the matrix. The matrix. The matrix right there is what it might be. Hold on a second. Let me just get some brackets around the edges, because normally you see that. I'm making my own custom brackets from scratch here. That's subtracting shapes. This shape minus that shape. Okay, and so that's what the matrix looks like. Something like that. Why did it change the spaces there? Okay. All right, that's what a matrix is. Coding Gorilla says, I still struggle with 2 plus 2, but I'm told it equals 5 these days. So welcome to college, Campbell. That's what Pudding says. Welcome to college. So that's what a matrix is. We'll probably look at this and maybe visualize these, later on in the year. That's my guess.
Okay.
Okay? All right. Back to your machine. Okay, so we got the matching vector. There's 2 things we need to do if we find it. One is we need to remove it from the list. So we need to go into super vectors and say remove and pass in the matching vector. Okay, you good with that?
Yeah.
The other thing we have to do is we have to call destroy, passing in the game object. And now we've implemented the code that we kind of wrote out on my machine. This code right here, where we just kind of said, hey, check to see if A is already in the list. If it is, delete the game object. Did we do that? Let's check to see if we did that. There it is right there. If it's not unnamed, in other words, it's named, we're going to remove it from the list, right? That's what we said to do right here. Delete the game object. It's the super vector. You look like you're not looking at it.
Sorry, yeah?
Can
you say it again?
Yeah, I can. So here, check to see if A is already on the list. See that line of code? That corresponds over on your machine to, well, it's not really quite there. We go to remove name vector. Remove name vector comes in here. We didn't actually, one thing I didn't check here is if it's not on the list, then we're going to get out. We'll exit. We're not going to remove it or destroy it if it's null. So this will only be true. How much of this are you getting?
I'm getting a lot of it, but some pieces are a little bit confusing.
Are there questions you want to ask right now?
No.
Do you want to see it run?
Sure.
All right, let's run it. I think it's going to work. Did you save it? Is everything saved?
Yeah, everything's saved.
Okay, so try A equals 1, 2, 3. Now change it to 4, 5, 6.
A is equal to 4, 5, 6?
Yeah. And we should see that one vector change. Now put in coordinates without anything, so we test the live vector, throw the live vector in another direction. Different coordinates. You need another set of coordinates. There you go. There's the live vector. Now say A equals 1, 2, 3 again. Well, your live vector is changing as you do this. So it's gonna show up right on top of it.
Oh, right.
So we want to maybe keep the live vector somewhere else.
No.
Fine. There's your live vector. Now say A equals, and now it's that, but now you can move it around again to 4, 5, 6, or whatever you want. So now we've got that. Okay, cool. Now change A to B. Okay, now change B coordinates. See, there's your B. You get it? You
It
got
works.
it. And you get a B. Now we can come in, and I'm going to just switch over to your machine. We can say a C is equal to, goes from, I'll even say goes from 6 to 3 to 12, 13, 14, 10. That's really far out there. All right, let's change it to maybe 9. And 8, 4, and 5. There you go. So that's kind of cool. Maybe make it -5. Maybe make that a -9. And a -4. There you go. It's cool. See what's going on? We got some vector kind of addition kind of things going on is what we're doing. We've defined C as that. We've defined A as the other piece.
Can I try something?
Yeah, of course.
So it's just reversed. Oh my god, that reminds me of what we had before.
Right. Now I want to do this. I want to come in and I want to say C dot set color.
This is what we want to be able to do, right?
Yeah, I want to pass in. Do I want to pass in like a hex string here? I'm not sure what I want to pass in. Yeah, maybe a hex string. I want to pass in like FF00FF. Why doesn't that work?
I'm not sure.
Why is it not changing the color?
We don't have code to say that,
I
right?
haven't written any code yet. It's the easiest answer in the world. I want to make, let's go back to our Regex Explorer and make it so we can parse this and understand that. Can we do that?
Yeah.
All right. The Regex Explorer looks like it's already running. Okay, so I want this to be my sample.
You might want to full screen it.
Yeah, I'll full screen it. I want to be able to say A.set_color. And then I want to pass in that, and then like, you know, FF0000. Do I want to do a hex thing? Hex string? Maybe I did. All right, so to get a match on this, what I need to do is I want to first match.
I love trash.
Aww.
All right, so we're gonna get this. That's gonna match our A. See the vector name found A? Right that.
Wait, 1 second. Okay, you're on the wrong screen.
Oh, I'm sorry. Set color, open paren. Whoops, we got to escape the open paren, right?
Backslash.
We are then going to need to have the pound sign. Then we're going to need a, you need to have a certain number of digits. Actually, we need it to be a hex character right here. And the hex character is going to be, I think it looks like this, Campbell. 0-9A-F. Like that, in brackets. That's a hex character. And we're going to need 6 of those. So I think I just do this. And then we're going to need the closing bracket. Now those 6 characters right there, we want to give that a name. And maybe include this. So if I want to give that a name, I need to put it in parens and I need to give it a name. Under the syntax for a name, we're going to call this hex code. And then paste it in there. Is that what you were going to say?
Yeah.
Okay, cool. So now take a look at what we've got here. With just typing this in, working this here, we've got now a class. We're going to call this our set color class. Okay? And it's going to have 2 properties, one called vector name and one called hex code. See it?
Yeah.
And then we're going to be able to type things like this and watch what happens as I change, right? If I change this, right, the code changes down below. See that? I mean, not the code, the answer changes, right? So it's going to be able to get that for me easily and quickly. The only thing I'm not sure about is, can we use a hex code to change color? I need to find that out. Let me go to my machine here. Switch over to my machine.
I don't know about Unity. In Unity.
Can I set a color using hex in Unity? So I'm going to type in C# Unity set color hex. I'm going to use a hex color. Color Unity, tries parse HTML string. That's the code we're going to use. Right there. Yeah, we're going to use that. Okay, cool. Cool, that's what we'll do. And that's how we'll change it. So we want to be able to set the color. So let's copy this code right here, the set color code. I wonder if I can just copy this, because I don't, the regex helper we already have. Now let me copy just that. Let's go into over here. Let's paste it in and then move it to its own file. Oh, wait, I think we found problems doing this, as I recall. And what we've taught ourselves to do, or what I've taught myself to do, is come in here, create a new script, and then paste it in the new script. So we're going to call this set color. Oops. Shoot. That's what I meant to do. And then double click on that. And then we're going to replace their class with this class, set color. Okay? And we're going to need to add, just hit Control dot here and use that right there. And that's it. So we've got set color. Now what we can do is we can come back over into our game logic, and whenever what we're doing here is text change, we're basically saying, hey, can we find a super vector from it? If we can, then we do some super vector thing. So I'm going to extract all this into its own method called, do super vector thing.
That might not be the best name.
What do you want to do? Call it create super vector?
Yeah.
It's like create or update super vector. Okay. Then I can come down here, do the same thing. Set color. That's equal to set color dot create, passing in the input text dot field, just like we have, or the input field dot text. I mean, just like we have up above. See on line 49?
Yeah.
Okay. So now then I can say, hey, if that's not null, then holy cow, we can set the color. Okay, so now what I'm going to do is I'm going to say call set color, and which is a method we're going to need to create, or maybe we'll call this change vector color, so it's not so ambiguous with the other name. And we're going to pass in vector name and set color dot hex code. We're going to declare that. You want to declare that for me? I'm going to copy this line of code, this code from...
Huh. Did I press the wrong key?
All right, and now here's what we have to do. We have to... Well, tell me what you think is going to happen here. Give me a sense. I'm going to just paste in that code that we had before, and we'll do that. But what do we have to do in change vector color?
I think we're gonna have to set the color of it, correct? Or, right? We're gonna have to do set color on the variable that we just created.
Well,
called color, right?
We need to set it on the correct vector.
Oh, right.
We have the vector name.
So,
how do we find the correct vector if we have the vector name?
well, I'm not sure.
See this line 35?
Yeah?
It does that. Let's extract this method and give it a good name called getVectorByName. See that?
Yeah?
Now we can basically copy this code and bring it down to our set color. And also, by the way, try parse HTML string. This is this weird sample color they're passing in. We don't want to pass there. What are we passing in right here?
Vector, no. I'm not.
You're close. Look
Just
at
a color, right? Does it matter what color?
It's the color that we typed in. The color we typed in the input text field. I want to make sure you're following this. Look at this. Look at the call from here. When we call setColor.create, it creates that class that we just built right here. That class populates vector name with A, or whatever we've typed in as the variable name, like my cat, like that, right? It puts vector name there. See it?
Yeah.
So it's going to have that in the field already. So if it's not null, we've got it. Look, we call change vector color. What do we pass to it? Set colors to parsed out fields. Vector name parsed out by what I typed in. Whatever I type in, right? I might say, something else up here, like 0000 FF, which is going to be totally blue. So we're passing in the hex code to change vector color. Change vector color is getting those, receiving those in this parameter and that parameter. My question to you is, what do we send out here?
Hex code, right?
Yes. It's hex code. Boop. That's what it is. We get the color back out. We're going to have to use this in here. Matching vector. We try to get the vector by name. We might want to do this first. Do we get the vector? So at this point, now I've got a game object, Campbell.
Yeah.
And I've got a color. That's a new color. How do I change the color of the game object? Go. Figure it out.
Set color, right?
I don't know. You figure it out. you do it. I don't know. You were the one who looked up how to do this in Unity, I think, right? Remember we were looking at Unity? It's not here. It's a Unity thing, right? You have to get the mesh, or you have to get the renderer, or you have to get a material. You have to get something and change its color. In the cone, remember?
Yeah.
That's what we're looking for. What is it? How do we change the color?
We have to access the material.
How did you do it here? Which one did you change? What material? What did you access?
What do you mean?
How did you change it here? When you were in Unity, I saw you change the color to blue. How did you get that cone changed to blue? How did you do it? What properties did you change?
I changed the properties in this material, which we can access from the mesh renderer.
That material is used everywhere.
No, it's not. It's only used here.
But it's cloned, and therefore the material is probably cloned. Which means if we change the material,
we could wait. No, we could when it instantiates. I don't know if this is true. It might not be, but I think it also instantiates a new material.
A clone version of it?
I think. Wait, can I try something?
Yeah, always.
It might also I think it might also, if you change the material via the mesh renderer, it might not change it for everything. It might.
So we could look for that. So we try to find the mesh renderer, we go through the materials, find the material, change the color. Do you agree with that?
Yeah.
The pieces and comments are the things you're going to want to use. The game object is the cone. At this point, matching vector.gameObject is the cone. See that comment down there?
Okay.
2 lines below you?
Got it.
That's the object. The color is, we just got it by calling try-parse HTML string. This could work. I'm feeling good about it.
So this is the cone,
get you out
right?
faster. What?
This is the cone?
Yes, that's going to be the cone. Remember angle brackets here to specify the type of the component. This is a generic method.
Mesh render. It's this, right?
Yep, exactly. Get component. And then you can hit the code rush key. I think that'll work there maybe at the end of the line.
Right.
Declare local for it. Don't forget home and end keys. Practice hitting those. Really fast ways to move through the code.
Okay, so what are we going to call this, I guess?
If you use the code rush key here, cut what you just typed in. All right, you can do that too, but you need to give it, it's got to be of the right type. So it's
Genisco 7, where are you? We need your help.
Genisco 7's here, kids.
Oh, God, all right. Here, right now.
With the drones. Dr. Campbell's machine. All right, you've got your cone mesh renderer. How do we change the color?
I believe on here.
We have to find the material, I think, right?
Yeah, we can do mesh.
Sorry, I moved the mouse.
Yeah.
My bad. I think it's just material.color. I just found an example for it. Take a look at my screen. Right here.
Yeah, I believe you can do that.
Material.color. Try that.
You think I can do it directly here?
Yeah, you can do it there, but I would just do it on the next line.
Yeah.
It's easier to read.
Oh! Yeah. Material dot color is equal to color dot.
No, just that's it.
Oh, right. This color.
Semicolon. That's what you need.
Okay.
And then.
Wait, I want to see. Oops.
Do you remember out parameters? On line 59, that out parameter color. Do you have a sense of what's going on there?
I think so.
Okay.
It's changing it for everything, right?
From that point forward, it changes color. It declares it
Come on.
on method. What's happening?
It's maximizing on play when I didn't want it to. I just want to see. It isn't. Oh, right. We have to put something in here.
And this one, yeah, we're interested in what we see out on the. You can go to maximize if you want to see more.
So if we do 1 space 2 space 3.
Yeah. Set color won't work. You're going to need to create a variable, a named variable first. Named
right.
vector. So A equals something. Put it in a different quadrant. Yeah, a different.
No.
Yeah, your X should be negative. Good. Good. And then now I want you to say A dot set color.
Separately?
Yeah. Delete all that.
A dot set.
It's got to be case sensitive. We did not make it case insensitive. The C is also uppercase.
And then equal?
Nope. Open paren. Pound symbol.
In here or?
And then the 6 digits, they can be A through F. That's basically what they can be. So 0, 0. You can just do all zeros, and it will be black, which will be no change. But there need to be 6 digits. F, 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 F. Okay, this is going to go white, I think. You need 6 of them. Okay, there. You have 6.
I believe so.
It feels like it's not working.
Wait, let me just check.
We need to set a breakpoint. Let's set a breakpoint in code. Can we attach while we're running? Maybe we can. Let's set a breakpoint here. I'm not sure if that's going to work or not. And let's change the text. All right, see what we got. Okay, this data looks great. See, vector name is A.
Yeah.
Found the matching vector, that's good. And we parsed it, so we've got a color. Game object is there. Get component is null. Get component of mesh register on the game object is coming back null. The game object, it's not get component, it's get components in children. Remember, because the main thing doesn't have a mesh renderer.
Right.
Okay.
Right.
So this is actually, I think, going to return a list of these. What I think it's going to return. We're going to have to continue, stop, and restart. Is what we're going to have to do, because edit and continue does not work with Unity. So is that going to get? I think I would get components. Don't I want to change it in 2 places or only one, Campbell?
No, you want to change it in 2 places.
So I got to get components of children, which is going to return a list of these mesh renderers. So look, there's the list again. Code mesh renderers. Then we're going to grab that, and I'm going to type in FE space to get that for each right there. And now that I'm inside here, then I've got my variable is going to be called mesh renderer. Okay. What's wrong over here, though? Wait, what's it come back? Oh, it's an array. It's an array of mesh renderers.
What's the difference between a list and an array or a dictionary?
Yeah, so that's a great question. And I'm not enough, I'm thinking of a really, I don't have a great explanation in my head, but an array in general tends to be a little more, less type safe. So you don't get that, you can actually put wrong things into an array, I think, sometimes. An array is a very simple way of having the list of things out there. A list has more sophisticated methods on it, like first or default. So I can do those kinds of things with an array. And a dictionary is designed for fast access. So it's where I have a key. So a list doesn't necessarily have to have a key. I just have a bunch of items together, a bunch of cookies in a bag, right? But if I wanted to individually access each cookie with a name, like I made a cookie, decorated it to look like all my friends, and I wanted to say, let's bring the Eli cookie out, a dictionary would be what I would use because it's very fast. Generically speaking, an array is fixed size where a list contains, oh yeah, that's true. An array is a fixed size, so you say I'm going to hold 9 elements, generally, when you create it. Where a list contains various arrays, which allow a list to tell you like fixed size. So,
Huh?
You're breaking my machine? What's happening with my overlay? That's kind of cool. Okay, so now let's try it. So now what we're doing is we changed it. We're getting the components in the children, and let's run it.
That was really weird.
Follow those same steps again for me, Campbell. Whoops, I started to stop you. Follow the same steps again.
Okay.
So create a vector, name it A. Now say A dot set color. And make it white. Nope.
Oh, oops.
If you want to type in color equals, we can change this. We can just easily go into a regex explorer, change it so it matches A equals the color equals.
No, fine.
And then no code changes, right? You just paste that in. Okay, we're in. Set a breakpoint on line 65 and clear the one on line 53. Thanks, Coding Gorilla, for that declaration. Now hit F5 to run, or click on Continue up at the top if you'd rather. Okay, cool. We're setting the color. Also, look at the existing color. Look what the debug visualizer is showing you. It shows you it's already equal to 0, 0, 0, and we're going to change it to 1, 1, 1. See that? Isn't that cool?
Yeah.
So we see that there's going to be a change. Go ahead and clear the breakpoint and hit run.
F5, right?
Yeah, F5, exactly. Perfect. Look at that. Now let's create B and make it red. I'll tell you how to do red. Copy this to the clipboard red, by the way, so you don't have to type this in next time.
Okay.
Awesome. It is awesome. Thanks, Coding Gorilla. Have B point down, you know, into another quadrant.
And then... Oh wait, that actually looks super cool.
Yeah.
Right here?
It does. You can paste in, I think. You have the... And just change that to a B at the front, and then change the color to red, which is going to be 2 Fs followed by all 4 zeros. And as you make things legal, by the way, there's the red. Sweet. Sweet. Now watch this, Campbell. Watch what you can do. This is what's so cool. Watch this. Now that we've set the color for B, oh shoot, what happens if we say B is equal to 1, 2, let's make this negative 4, 2, 3. It goes back to black. It doesn't remember that it's red.
I think we're gonna have to create a variable for its current color every time we create.
And store it somewhere. I think you're right. We'll have to do that. We'll do that next show. That's what we'll do. The other thing that, I don't know if you like this or not, this is something that at first I thought would be cool, but watch what happens. If as I change this, it's making, it is going out and it's immediately updating, and that may not be what I want.
Do you want?
We want to make it so that when I hit enter, it makes the change.
Okay. So that it's not constantly changing, right?
Say that one more time.
So that if you have a live vector and you want to change it, it isn't just...
Yeah, and then so that we kind of type it in, then we hit enter, that sort of thing.
Okay.
But it's not bad. It's like, cool. Set color. Let's do this. Let's go to, let's open up a browser. And let's go to HTML color picker.
I've used this before, I think, once.
Yeah, pick a color and then paste it in. Grab the hex code down there, whatever you want. Pick the color you like for this, for the vector. Copy that. Yeah, exactly. Copy that to the clipboard, and then pass that into your set color. Type in b.setColor for that, and watch that.
We might want to have it so that some colors, like basically red, blue, green, some of just basic colors that you would use most, you can just do b.setColor blue.
Yes, we could do that as well. Cool. Look at that. It's not bad. right? Not bad. We're kind of getting closer to what we want. Genesis7 says, you know, overlay of corner, those gates could need corner graphics too. Gates. I'm not sure what you're talking about with the gates on that. Are you talking about the drones, or are you talking about what we're doing in the on the show here? I'm not sure what that is. Campbell, I'm going to get a. Is there anything else you want to do? I was going to get a raid going here. You want to create a new vector? Why don't you try to create a vector pointing right at right between us, right here.
Okay.
Unless you have something you want to do, and
nope.
I'll set up a raid. Oh, you're just redefining B. Okay.
Yeah.
Yeah, we got to make it so we don't lose the color. I was going to do a C, keep that old B one out there with the color it was.
Oh, right, we need a negative Z.
Yeah, negative Z.
That's pretty close, I would say.
All right, cool. Excellent. We'll send you over to Chael Codes, everybody. Thanks for joining us. And Campbell and I will be back tomorrow to take this another step further. So we learned about lists today, Campbell.
Yeah.
Right? And here we go. Great, everybody. See you tomorrow.